Hello and welcome to this video where once again we continue with motion graphs. In this video I had promised to take you through the process of determining the gradient of a line or the gradient of a tangent at a point on a curve. And I will take you through the determination of gradient as we do in mathematics when we draw graphs. We usually use y-axis, x-axis, and then we plot the points of a line or the points of a curve. For instance, I will start with a straight line, maybe through the origin. It may pass through the origin or it may not pass through the origin, provided it's a straight line. And I take some 2 points like this point here. Its coordinate is x1, y1, and this point here, its coordinate is x2, y2. So we usually express the coordinate of a point on a graph or on a line starting with the x coordinate followed with the y coordinate. And the smaller value of x is what determines whether it is x1 or x2. So this one will be x1 and then y1. This point will be x2, y2. That means that at this point here, the value of x is this one here. It should be 0.4 because you can see from 0 to 1, there are 5 spaces. And if you divide 1 by 5, you get 0.2. So this one should be 0, 0.2, 0.4, 0.6, 0.8, 1.0, and so forth. So I count in steps of 0.2. Let's go to the y-axis. The y-axis, the scale is the same. From here to here, this is 1. And therefore, each space is 0.2, just like along the x-axis. But these two scales need not be the same. I have deliberately made them to be the same in order to make you to understand this particular concept easily. So the value of x1 is 0.4 while the value of y1 is 0.2. When we come to this point, the value of x2 is 3.2 while the value of y2 is 1.6 because this one is 1.2, 1.4, 1.6, and you can see that. So that now we can talk about, we can draw a right angled triangle here with the edges of this triangle touching this point, as shown here. So this one is a right angled triangle. Starting from this point, its hypotenuse runs along from this point to this point. It just runs along this line. Now let's ask ourselves, how do we calculate the gradient of this particular line? We get the change in the value of y divided by the change in the value of x. For instance, for us to do that, we'll need to read this value accurately and this value accurately because it's going to give us the change in y, and then read this value accurately and read this value accurately because it's going to give us the change in x. This symbol here, this triangle here with a y is read as delta, delta y, delta x. So we are going to find how delta y changes with delta x, or how the y values change with the x values. In other words, for us to determine the gradient, we are going to determine the ratio of delta y to delta x. Delta y is the change in y, while delta x is a change in x. And that is exactly what we have here. So gradient in mathematics is usually expressed using the letter m, and it's given by change in y divided by change in x. And that is what we have here. So this is exactly what you do in mathematics. So you'll go and read y2 minus y1 divided by x2 minus x1, just like I helped you to read here. So you can see the value of x2 is 3.2, while the value of x1 is 0.4. 3.2 minus 0.4, while the value of delta y is 1.6, just like we had read, 1.6 minus 0.2, minus 0.2. And this gives us 1.4 divided by 2.8, which is 0.5. So it is just as simple as that when it comes to determining the gradient or the gradient of a tangent which is drawn at a point on a curve, as we are going to see very soon. So suppose we have another line which is parallel to this line, but they are not running along the same line. For example, this point and this line and this line, they are parallel. So what is the gradient of this second line? This one here. You'll see that this change divided by this change will of course give us again 0.5. In order to tell that two lines are parallel to each other, they must have the same value of the gradient, the same value of m. So you can take your time, pause the video, calculate the gradient of this line just by using this change, divide by this change, and you'll find that again it gives a 0.5. That proves that this straight line and this straight line are parallel to each other. So remember that two lines which are parallel to each other, they are like that because they've got the same value of m, the same value of the gradient. So you can't just tell just by looking at them like this that they are parallel to each other. There might be some slight change. One might be steeper than the other one, just slightly steeper than the other one, and when the steepness changes, then the gradient is said to change, and therefore they are not parallel to each other. But in this case, the steepness here and the steepness here, they are exactly the same. In fact, the other word for gradient is steepness. How steeper is this line compared to this line? So the steepness or the inclination of the line is what we refer to as a gradient. So I hope you've gotten the first point of how to determine the gradient of a line, especially the gradient of a straight line. You just need to get change in y divided by change in x, and when you are reading these values, you ensure that this one is x2 y2, this one is x1 y1. And when it comes to finding the gradient, we usually start with the change in y divided by change in x. It is not the other way around, because I've seen some students doing change in x divided by change in y. No. Remember, gradient of a line is given by change in y divided by change in x. So having said that, let's look at a situation whereby the two lines are not parallel to each other. For example, this line here, this line, we can again determine its inclination or its gradient, or how steep it is. And you'll find that the gradient of this second line, which is m2, is much steeper than this one. Even from the way it looks like in the graph, you can tell this line is steeper than this one. That one is an important skill. Okay? So, however, let's just determine the gradient of this one. You'll find that change in y will be 4 minus 2. 4 minus 2. Change in x will be 3 minus 1. 3 minus 1, which gives us 1. So it's 2 divided by 1, which is exactly 2. Okay? So you can see that the magnitude of the gradient tells us that this line is steeper than this line. It's just as simple as that. So this one is proof that this line is steeper than this one. even before we calculate the gradient, we can be able to tell visually that this one is steeper than this one. That one is a scale that is so important in physics. So remember, when two lines are parallel to each other, they've got the same gradient. But if the gradient is different, then they are not parallel to each other. And this one is less steep compared to this line. While we are at this particular point, you can tell that if a line is parallel to the x-axis, if it is horizontal, definitely you can see that the change in y will be 0. And when you divide 0 by any number, you just get 0. So a line which is parallel to the x-axis, its gradient will be 0. Remember that. Now, it does not matter whether we are using negative values or positive values to determine the gradient, or sometimes positive. You know, this line, like for example in the previous graph here, you can see that y values are positive, x values are negative, while here you can see x values are negative, y values are negative too. It does not matter. If you are to determine the gradient at this point, following the same rule which we have used here, that the gradient is delta y over delta x, and you do y2 minus y1 divided by x2 minus x1. If you follow that rule, you will find that it does not matter whether this graph is in this quadrant or in this quadrant. The gradient, when calculated when it is in this quadrant, is the same as the gradient when calculated in this quadrant. We could even shift this right-angled triangle to be a stride, or to start from here in such a way that some values are in this quadrant and some values are in this quadrant. Or for this case, some values, maybe the right-angled triangle starts from here, comes like this, and then ends up here. So some values in this quadrant, some values in this quadrant. It really does not matter. You'll find that the gradient will always be the same. So provided it's a straight line like that, the gradient remains the same. It does not matter where the line is. Okay? The other point I'd like you to observe is that it does not matter the size of this right-angled triangle. It could be smaller, very small right-angled triangle here, or a big triangle like we have drawn, or a triangle that takes the whole of this line. It does not matter the size of the triangle that you use, the gradient will always be the same. And when it comes to a straight line, again, it does not matter whether I draw that triangle here, or I draw it here, or I draw it here. It will always give us the same value, the same value. The only observation we'll make here, or the only caution that I'd like to mention here, is that when we are finding the gradient of a line in physics, it is usually recommended that you draw a large triangle. A large triangle. Don't draw a small triangle. That is the only caution. So, I will not go into the reasons why we use large triangle, while even a small triangle would have given us the same value. Just follow that rule. In physics, we will always draw a large triangle. And we must show that triangle with solid line, and then the read-offs, we are going to dot them. We are going to dot them like that. Show the read-offs in your graph that you're going to draw. Here, I avoided showing the read-offs because, for one, I didn't want to crowd this video with a lot of details, because I wanted you to concentrate on one particular thing at a time. But when you are drawing your graph, make sure that as soon as you draw this right-angled triangle using a solid line, okay, do not shade it like the way I've shaded it, okay? Don't shade it. Just draw this right-angled triangle, touching the line at this point, touching the line at this point, and it should be a solid line. After that, if it is not touching one of the axes there, then dot this particular line like that, so that it is clear that this is the value that you are reading. Do not write down this value on the graph. Go to the space that is provided where you're going to write down that value. Again, you're going to dot this line downwards until you get the reading that you have here, which in this case is 2.8. So those are the things that I would like to emphasize. The other thing that we want to understand from this video is that gradient of a line can be positive or negative. When a line is sloping like this, downwards like that, its gradient is negative. It is sloping upwards. Here it is sloping downwards. It's like going down a hill. The gradient is going to be negative, but when you're going up a hill, the gradient is going to be positive. That one is an analogy that you can use in this case. So gradient of a line can be positive or negative, and we can even prove that the gradient of this line is negative, like we have done here. Find that the change in y will be 0.2 minus 2, because now we start from this coordinate. This is x1, y1, this is x2, y2, and you can see y2 is 0.2 while y1 is 2, 0.2 and 2, but the value of x2 is 2.8 while x1 is 1. Okay, so when you do that, you'll find that the negative sign comes in automatically. And do not exchange these values. Some students think that since this one is 2.8 minus 1.0, then this one should be 2 minus 0.2. Do not exchange. If you have decided that this is your x1, y1, then this one is your x2, y2, then this should be y2 minus y1 divided by x2 minus x1. Don't be dictated by the magnitude of these values and you tend to think that you've made a mistake. Just follow the rules. If your y2 is here and your y1 is here, do y2 minus y1. That means your x2 is here, so you'll do x2 minus x1. Okay, and you'll find that it will either be positive or negative. I hope that one has been understood. So gradient, sometimes it can be steeper, sometimes less steep. Gradient can also be positive or negative. Now let's look at this, whereby we want to look at a graph which is now a curve. I've given this particular curve like this, whose gradient is increasing like that. And how do I tell that the gradient is increasing? I just need to pick a point, like for example this point here. Once you pick a point, we can find the gradient at that point. We can find the gradient at that point. How do we find the gradient at a point on a curve? How do we find the gradient at a point which is on a curve? Okay, this is what we do. We are going to move our ruler in such a way that the ruler just touches the curve at that point. I hope this one is clear. So I'm going to zoom in at this point so that you can be able to see that it is at this point where I've drawn this line which just touches that point on the curve. This line is referred to as a tangent. This line here is referred to as a tangent. And then I'm going to draw the right angled triangle on that line. Okay, on that line. Sometimes the students do this. They will come to this point, but then they end up drawing the line here on the inside. Do not do that. Don't do that. The line is drawn on the outside because this line is just meant to just touch that point, one point on the curve. The tangent is meant to touch the curve at only one point. When you draw it here, it is touching the curve at 2 points. Although it's going to give you the same value, but it's not as accurate as when it touches the curve at only 1 point. Okay, the moment you draw that tangent at that point, draw the right angled triangle and then find the gradient of that right angled triangle. What you are doing, you are finding the gradient at this point on the curve. Go to another point. Repeat the process. Okay, this line that I've drawn here is not touching the line exactly. I ought to have moved until it touches that particular point. Okay, do the same. Go draw a tangent at some other point, and you will agree with me that this slope, this gradient here, is less steep compared to this slope here. So you can see that starting from this point, the gradient is increasing. The gradient is increasing. The gradient is increasing like that. So when you see a line which is curving upwards like that, and you think about finding its gradient, you should automatically know that the gradient of that line is increasing. The gradient of that line is increasing. And we have proved by using these tangents. So that is what I had for you in this particular video. Go through the video once again to ensure that you understand each and every point that I emphasized. Each and every point that I emphasized. I started with a simple line and how to draw the line. Then we went to how to find the gradient of that particular line by doing delta y over delta x. Then we went to a situation where we compared two lines which are parallel, and we are able to see that two lines are parallel if they've got the same gradient. Then after that, we saw how we can be able to tell if a line has a steeper gradient or less steep gradient. Just by looking at them, we can say this line is steeper than this line, but we can go ahead and prove that the gradient of this line is higher than the gradient of this line, which is 0.2. After that, we looked at a situation whereby we agreed that gradient can either be positive or negative. Okay. After that, we looked at gradient, how the gradient changes on a curve. In this case, the curve that I've given is such that the gradient is increasing. In some other curves, if the curve is going like this, then the gradient should be decreasing. We even talked about a situation whereby the gradient of the line is 0. So go through the video once again, because learning is about a repetition. The more you repeat a concept, the better you understand that particular concept. Okay? And then I will see you in the next video where I'm going to continue this process and now insert physical quantities to the y-axis and a physical quantity to the x-axis, and then I will show you how your gradient acquires units. See you in the next video.